Hey guys, Mr. Nielsen here. Today we're going to start our graphing or linear equations unit with rate of change. At the end of this video, you should be able to find the rate of change between two data points, and you should be able to put your answer in context of the problem. Okay. The rate of change allows you to see the relationship between two changing quantities. Okay, so it only applies to two things at a time, but that's going to help us out. In a line, the rate of change is going to be constant. Okay, so if we're looking at a straight line, we know that that rate of change is constant throughout the line. So no matter which 2 points we choose, the rate of change will be the same. The rate of change will be the change in the y. We'll say the change in, let's just say y value over the change in the x value. Okay. It's going to be important for us to know what those values are because the units will matter for us. Okay, so we can find the rate of change from a few different forms. We can find the rate of change from a graph. Okay, and so what I'm going to do is I'm going to highlight a few points here. So we're going to look at point here, points here, point here. So you see these 3 points. Okay, and then we're going to answer a few questions. So from point 1 to point 2, so notice these 2 points, I'll label them, I guess, 1, 2, 3. From point 1 to point 2, how much does the y change? Okay, and so if we look at the y here, this y is, or this point would be at 0, 0. This point would be at 2, and we'll just say 1/2, so cost in dollars and 50 cents. Okay, and this point would be at 6, and the cost would be $1.50, so 1.5. Okay, so how much does the y change from point 1 to point 2? Well, before it was at 0, next it says 50 cents, so we can say it changes 50 cents. It goes up 50 cents, so positive 50. Okay, how much does the x change? We go from 0, remember that we go x comma y, so from 0 to 2, changes 2. Okay, it went up 2. What is the rate of change? Okay, and so what we'll have in our rate of change is the change in the y value, which we had 50 cents, and the change in the x value, which we have 2. Okay, and so I can really simplify this, which I will, and I'll say 25 cents for every 1. Okay, so 50 cents for every 2 ounces, or 25 cents for every 1 ounce. Okay, and what does that mean in this problem? That means that the price of oregano is 25 cents per ounce. $0.25 per ounce. Okay, so notice up here, it's measured in dollars, that's why I kept it in dollars. But 25 cents per ounce of oregano, that's what the rate of change means. Alright, so looking at the same graph, let's look from point 2 to point 3. We'll notice here from point 2 to point 3, at point 2 we were at 50 cents, and at point 3 we're at $1.50. So how much does it change? Well, in this case it changed $1. How much does the x change? Well, we went from 2 ounces to 6 ounces. So 6 minus 2 is 4. The x changed 4 ounce changes. Okay, what's the rate of change? Well, the rate of change is $1 for every 4 ounces. Okay. Now it says, how does it compare to the rate of change from point 1 to point 2? Notice that we have $1 for every 4 ounces. But again, we said $1 for every 4 ounces. We could simplify this and say 25 cents for every 1 ounce. Okay, so how does it compare? It's the same. Which makes sense because, like we said in a line, the rate of change will remain constant throughout. Okay. All right, now you have an opportunity to do that same thing with a tank of gas. Here, I'll help you out and give you a few points that you should look at. Okay, so I gave you a couple points there. One point is at 0.15, and the next point is at what looks to be 155. Okay, answer these questions, find out the rate of change, and then tell me what that rate of change means in the situation. So do these 4 problems for me looking at that. Okay. So we looked at how to find rate of change from a graph, and now let's look at how to find rate of change through a table. Okay, so in a table, really it's going to be a similar concept in the sense that we're going to be looking at the way that the x's and y's change. Okay. In a table, remember that the independent variable, the x, typically goes first, and the dependent variable, or the y, goes next. Okay. All right. Now, we want to first make sure that there is a constant rate of change, and so what we can do, and what we'll do in this case, is we'll say, okay, how much does the x change from one thing to another? So, 2 here, 3 here, 1 here. Notice that those numbers are not the same. Okay? And so as we look over here, from 75 to 105 is a 30 change, $30 change. From 105 to 150 is a $45 change, and from 150 to 165 is a $15 change. Again, those numbers are not the same. The numbers that we're looking for is the rate of change, not is the cost changing the same or the number of tickets changing the same. It's the rate of change. It's the rate of change staying the same. And so we can find that rate of change by taking the change in the y's, 30, over the change of the x's, 2. 30 over 2, 45 over 3, 15 over 1. Are these all the same thing? And if you typed them all into your calculator, you would get the answer of 15. Okay, so while it's not important that the answer is 15, it is important to see, for this question, is the rate of change constant, that the answer is the same for each of these. Okay, the fraction says simplify to the same for each of those if the rate of change is constant. So in this case, it is, yes. You can see that the rate of change is 15. Scoop this up so it can stop moving. Okay. So what is the rate of change? Like we said, 15 over 1. And remember that it's going to be important for us to realize the units here. 15 is the cost, $15, and 1 ticket. So what does it mean in this problem? Each ticket costs $15. All right, let's look at this next table. Again, we're not really overly concerned about what these numbers are individually on each side, so I'm going to find them. 5, 3, 4, so those are the changes from one point to the next. 20, 10, 50, again the changes from one to the next. Alright, now once we find those changes, then we'll find our rate of change by making our fractions. So 20 over 5, 10 over 3, and then 50 over 4. as we simplify these, 20 over 5 simplifies to give us 4 over 1. 10 over 3 doesn't simplify any, and then this simplifies to give us 25 over 2. Notice that these are not equal to each other. Okay, this rate of change is not constant. So the answer is no here. Okay, and because the rate of change isn't constant, it means we can't answer this question like what is the rate of change. In a line, we have a rate of change. Here, we don't have that. Okay. Okay. So what does it mean in this problem? I guess there's no constant rate. Okay, so kind of not applicable again. There's no constant rate. I'll say in NA, but I'll also say there's distance ran isn't linear. Okay, and that just means that he is not running at a consistent speed throughout the race or this run, whatever it may be. Okay, so we see a situation where we had a constant rate of change, and so we saw the linear model there, and we could say that we could find a rationale or reasoning for the rate of change, and here we have one that wasn't. Okay, and so then we can see that that's just not linear. Okay, so we found the rate of change from a graph, we found the rate of change from a table, and now we can find the rate of change from a situation. Alright, so let's look at number 3. We have a baby giraffe was 70 inches tall at birth and 103 inches tall after 3 years. What are the 2 data points we can get from this? Okay, so typically when we're given a situation, what we'll want to do is make a table. Okay, we'll make a table from the situation and then get the rate of change and the information we need from that. And so notice the 2 pieces of information we got was height and I'll do height over here. Height and age. Okay, and so the first age we got was that it was first born. So I'm going to say 0. Okay, that's 0 years old, and it was 70 inches tall. The second piece of information was that at 3 years, so the age is 3, it was 103 inches tall. Okay, so I've made a table, labeled it. So these are our data points. This is the data we got. And so now they're asking us what the rate of change is. And because we only have 2 pieces of data, or points of data, then we can find it. There's no way that it wouldn't be linear from all that we know at least. And so the change here is 3, the change here is 33. And so our rate of change is 33 over 3, but we should simplify it to say 11 over 1. So 11 inches, those are our units here, inches tall, for every 1 year. So what does it mean in this problem? It looks like the giraffe grows 11 inches per year. Okay, and so there's our situation and how our rate of change fits into it. Alright, so just as we found the points of data from the situation there and found the rate of change, I'd like you to do that for this last problem. So you got 2 problems that I'm asking you to do for the notes here. This situation with the eggs on the back side, as well as the gas tank rate of change on the front side. Alright, so now you should be able to find rate of change, whether given a graph, a table, or a situation, and you should be able to say the context or what it means for each problem. See ya.